Bismillah ar-Rahman ar-Rahim. Inshallah, today I'm going to speak about distance relay zone calculation or zone reach. In previous video, I explained how the zone will be implemented in distance protection relay. But in this video, I will show you how to calculate the zone in distance protection relay. If you check this small single line diagram, we have substation A and substation B and substation C. The distance between substation A and B, assuming 100 kilometer, and from substation B to substation C, also 100 kilometer. And we see that the distance relay is worked by measuring the impedance along the line. So Z will be equal V by I. So that's why we need CT and BT as the input to the distance protection relay. So the setting what we have, it is zone 1, it is protect 85% with time delay instantaneous. Zone 2, 120% with time delay 0.4 second. Zone 3, 240% with time delay 0.8 second. And zone 4, 10% with time delay 1.5 second. Also we have two important parameters as we discussed, CT ratio and BT ratio. CT ratio 800 by 1 ampere and BT ratio 132 kV by 110 volt. So this is the parameter what we have. So that's why this the zone 1 is protect 85%, zone 2 120%, zone 3 240%, and zone 4 10% for reverse direction, for backup protection for the bus bar. So this parameter is not enough to calculate the zone calculation. Also we need to consider one important factor, it is conductor parameter. We need to know the positive sequence resistance and positive sequence reactance. So assuming it is double circuit or single circuit is depend about the conductor parameter. Assume the conductor parameter we have positive sequence resistance. Assume we have assuming 0.140 and reactance what you have 0.410. Assuming this is not correct factor, just I am assuming this value. So now by this value and this parameter, now we can start to calculate the zone and distance protection relay. But before I'm going to start the calculation, this is come for by the reactance formula. So we need to change to the boiler. So we change it to the boiler form. So we say boiler 0.140. So it will come in boiler form. It will come 0.433 with angle 71.14. Okay, before we start calculation, we need to change it from reacting formula to boiler form. So now we can start calculation. So zone 1, assume now, zone 1 calculation will be what? Will be the protecting area, it is 85% is 0.85 multiply line length. How much the distance between substation and A and B? 100 kilometer. Multiply by 100 kilometer. Multiply what's positive resistance and positive reactance for the conductor. It is 0.433 with angle 71.14. Okay, this value will give you the impedance at the primary side, but in the distance relay protection, when the setting will be implemented at the secondary value, not at the primary value. So if you mention this equation only, so we'll get the primary value, but we need the secondary value to be entering in distance protection relay. So how to get the secondary value? Just multiply by CT ratio, divide by BT ratio. Okay, so CT ratio how much we have here? 800 by 1, and BT ratio 132 kV divide 110 volt. Okay, so now let's calculate. So zone 1 will be equal So zone 1 will be equal 24.5 with angle 71.14 ohm. So this is the zone 1. I find the zone 1 at secondary side. So zone 1, the reach is 24.5, okay, with angle 71.14. Okay, so same things. Zone 2 will be say it is protect how much? 120%. So 1.2 multiplied by 100 line length multiply 0.433 with angle 0.14 multiply CT and BT ratio, assume 800 by 1 and 132 kV 110 volt. So the answer will be 1.2 multiply 100 0.433 multiply. So the answer will be 34.6 with angle 71.14 ohm. And zone 3, same things. Zone 3 is protect to 40%. So 2.4 multiplied by line length. Line length it is 100 kilometer. Multiply 0.4331 71 with the angle 14 multiply 800 by 132 kV 110 volt. Okay, so let's calculate 2.4 0.433 so the answer will be zone 3 will be equal 69.21 with angle 71.14 ohm. And zone 4 the same things, but as you know the zone 4 it's work in reverse direction. So zone 4 will be equal 10% is 0.1 multiplied by 100 line length, okay, multiply 0.433 with angle 71.14 multiply CT ratio and beta ratio 800 by 132 kV by 110 volt. So the answer will be 1 multiplied by 100 times 0.433 so the answer will be equal to 2.88 with angle 71.14 ohm. So this is why how to calculate the distance relay zone reach. Zone 1 we find it 24.5, zone 2 34.6, zone 3 69.2, and zone 4 for reverse direction 2.88. So so if you in our space, if you draw the characteristic like this, this is X, this is R, this is 71, okay, this is the zone 1, this is the zone 2, and this is the zone 3, and zone 4 will be here. This is zone 1, zone 2, and this zone 3, and this zone 4 for reverse direction for the bus bar. So this is how to calculate the distance relay zone. I hope this video will be clear for you.